Hi, we are from Group 19 and we are going to present our statistic project. The title of the project is The Impact of Caffeine on Study Duration Among University Students. And this is our team members.
Hello, my name is Nur Fatima binti Zulkapli and my matrix number is 227643 and I am from Group 19. I will be presenting about the introduction of the impact of caffeine on study duration among university students. So, for the introduction, I will start with caffeine consumption is widespread among Malaysians, particularly among university students. According to the Better Health Channel, caffeine is a stimulant that increases activity in the brain and central nervous system. It is commonly found in beverages such as coffee, tea, soft drinks, and energy drinks. When taken in small doses, caffeine can help individuals feel more alert, focused, and productive. One of its most well-known effects is sleeplessness, which is defined by the Oxford Dictionary as the inability to sleep. Because of these stimulating effects, caffeine has become especially popular among students who need to stay awake, maintain focus, and extend their study hours. While the effect of caffeine vary from person to person, it is believed that the resulting mental alertness and energy boost can last for up to 12 hours. Scientifically, caffeine works by blocking adenosine receptors in the brain. Adenosine is a sleep-promoting chemical that is produced in the brain during one's waking hours. Theoretically, the longer one's awake, more adenosine builds up in the brain and the sleepier one can be. By preventing adenosine from building up, caffeine helps to delay the process and helps the brain to stay active. Given these known effects, this report investigates the impact of caffeine intake on study duration among university students. Through a survey conducted among students, both inside and outside University Putra Malaysia, whether caffeine consumption is associated with longer or more effective study periods should be analysed. For the problem statement of our report, there are various methods students can use to stay awake and maintain concentration during their study session. Among these, caffeine consumption is one of the most common strategies. However, is there really a correlation between caffeine consumption and the length or effectiveness of study time among university students? Our hypothesis is caffeine-consuming students have longer study duration compared to non-caffeine consuming students. And next, for the methodology, to collect data for this study, an online survey was used to ensure wide distribution and ease of access for respondents. This method allowed us to efficiently gather responses from students both inside and outside University Putra Malaysia. The survey was created using Google Forms and was distributed to the public on 25 of April 2025 through various social media platforms including WhatsApp, Telegram, and Instagram. These platforms were chosen for their convenience in reaching the peers and wider community. A total of 90 responses were successfully collected. The survey consisted of 6 questions designed to gather information relevant to the research topic, which is on caffeine consumption and study duration. A copy of the survey question is provided in the appendix.
So for this question, on average, how many hours do they sleep per night? So from the pie chart above, you can see that almost half of the responses, around 40 students, sleep for 4 to 5 hours every night. And around 38 students out of 90 responses sleep for 6 to 7 hours per night. And there are 10 students sleep less than 3 hours every night. And the rest of the students get enough rest every day, which means they sleep more than 8 hours. So for the next question, do they regularly consume caffeine? So from this figure, it clearly shows that there are 62.2%, which means there are 56 students regularly consume caffeine such as coffee, energy drink and tea, while another 37.8%, which around 34 students barely consume caffeine. For this question, out of 90 responses, there are at least 30 students who consume only one caffeine beverage per day because most of them want to study longer. There are 26 students who consume zero caffeine beverage, and most of them barely take caffeine. On average, how many hours do they study per day? So, as shown in the pie chart above, there are 32.2%, the red one, around 28 out of 90 responses study for 2 hours per day, and 23 out of 90 responses study more than 4 hours per day. 22 students out of 90 students study for 3 hours per day, and the rest study for 1 hour per day.
Hi, my name is Amalia and I'll be talking about the hypothesis testing. So our null hypothesis, which is H null, is caffeine consuming students study for the same or shorter duration. And our alternative hypothesis H1 is caffeine consuming students have a longer average study duration than non-caffeine consuming students. So this is a one-tail right-tail test. So we've determined our significance level as 0.05, and we also assumed more than 4 as 4 for calculation purposes. So now we need to separate these two groups, which is caffeine consumers and also non-caffeine consumers, so that we can find the mean. So for caffeine consumers, the study durations, this is the data we got from our 90 respondents, and the number of caffeine consumers we got is 48. The sum of study durations is 136, and the mean study duration for caffeine consumers is 136 over 48, which is approximately 2.833 hours. And we're going to do the same for non-caffeine consumers. The study durations which we got from the data. So the number of non-caffeine consumers is 42. The sum of study durations is 107, and the mean study duration for non-caffeine consumers is 107 over 42, which we got approximately 2.548 hours. Next, we have to find the standard deviation for each group. So for caffeine consumers, the sum of squared differences from mean, we got 29.333. The variance is 0.624, so we got the standard deviation as 0.790. For non-caffeine consumers, sum of squared differences from mean is 25.143. The variance is 0.613. The standard deviation is 0.783. And then we need to find the test statistic, which is T statistic. So this is the formula: T equals to mean of caffeine consumer minus mean of non-caffeine consumer over square root of S square caffeine over number of caffeine consumer plus S square no caffeine over number of non-caffeine consumer. So just plug in the values that we got earlier, and then we got that T is equals to 1.716. Now we need to find the degrees of freedom, DF, for Welch's t-test. So the formula for this is DF equals to minimum of N1 minus 1 and N2 minus 1. N1 is our caffeine consumer, number of caffeine consumer, and N2 is number of non-caffeine consumer. So just plug in the values, and then we got the minimum is 41, so the degrees of freedom we got 41. And then we need to find the p-value. So we're using p-value calculator. Just do it right, take p-value, and then we know the t-score, which is 1.716, and then the degrees of freedom 41. So from this calculator we got the p-value is approximately 0.046855, and earlier we already determined the alpha, which is 0.05. So we can compare. Here p-value is less than alpha, so therefore we reject H null. So we accept the alternative hypothesis.
In conclusion, the results of the present study derived from a survey of 90 respondents and analysed via a one-sided independent sample t-test at a significant level of A equals to 0.05. The data indicate that students who consume caffeine have longer average study duration when compared to students who do not consume caffeine. This suggested that caffeine consumption is associated with extended periods of study time within the surveyed student population because it stimulates the effect that enhances alertness and reduce the tiredness during the study time.
That's all from us. Thank you.